Applications of radicals. There are some pretty good applications for radicals, one of which is the way that police measure a crime scene to verify whether or not people's stories are accurate as far as whether they were speeding, how fast they were going, and that's all measurable based on radicals after measuring the length of skid marks and the amount of damage that is done on a vehicle and that type of thing. Here are two more examples of how applications involving radicals can be applied. So what I've done here to simply begin this process is to type this into my calculator, and I'm going to go straight to the table here and find some values for which we'll solve this problem. So what I'm looking for here is I'm looking for the approximate distance that the marble will travel in 3 seconds. So I need this y value to be 3 seconds. So the first place I start is with 0, and obviously that's 0, 0. And then I skipped through to some of my table values because those are the ones that I'm most interested in, and those are the ones that are actually getting me nearer to and passing that 3 second mark. So at 85, that's 2.94, and you can verify this on your calculator. 88 is 2.99, and then at 89 it's 3.03. So we can say that between 88 and 89, this is in centimeters. That's when we're going to travel. It's going to be how far it will have traveled in 3 seconds. The graph of this is pretty long, so I'm going to go ahead and count by 10, 20, 30, 40, 50, 60, 70, 80 by tens. And then this one I can count by ones, 1, 2, 3. And then I know that between 88 and 89 seconds it crosses, or centimeters, it crosses the 3 second barrier. So I'll go ahead and set that up like this. This is going to be my time. The thing that's unique about this particular experiment is that this is one of those times where time is not the independent variable, and we're going to call this centimeters. Algebraically, we want to know when this equation is going to be equal so I'm going to go ahead and square both sides to begin with. 9 equals x divided by 9.82. Multiply both sides by 9.82, since there's division going on there, 9.82, and that's going to give me 88.38 approximately centimeters. My second and final example of this application is going to be right triangle. Right triangles, finding the missing side length of a right triangle is always found by using Pythagorean theorem. So the hypotenuse is going to be my 12. One leg will be 7. I've got to figure out the other one. So Pythagorean theorem, and that's going to give me a squared plus 49 equals 144. Subtract 49 from both sides, and that's going to give me a squared equals 95. Square root both sides. A equals the square root of 95, and that's going to break down into 5 and 19. Neither one of those are perfect squares, so there's nothing more I can do to this problem. The answer is the square root of 95. pretty simple, straightforward processes. We're just applying them to some real-life examples and other types of applications. So please expect this type of work on your worksheets.